Hello, this is Mr. Hausler. This is a test prep for Chapter 9. We have angles in Pythagorean. So on one of the EOs, it's going to be is at EO 17, which is just angle relationship. I'm going to keep going back and forth using my computer here. But one of them is interior angles and exterior angles. We have interior angles are inside the triangle, exteriors are on the outside of the triangle. So together we can create this straight line here. And all straight lines create 180 degrees. So I'm going to make up a couple problems. Here's one for interior. And here's one for exterior. So interior, if I give you this triangle and I tell you that this is 170 degrees right here, you should be able to find out what this guy is. Okay? Because it's 170 degrees on the outside. That means together this straight line should be 180. So 180 minus the 170 leaves a remaining 10 degrees. So that's 10 degrees down there. Okay, I can do the same concept with the exterior. I'm going to create a triangle. If I know that this is 35 degrees, I should be able to find this exterior angle right here by just doing 180 minus 35. I'm using up that 35 degrees of this straight angle. Leaves me with 145 left. 145 degrees out there. Another angle relationship we have is remote angles. So A is an exterior, and then C and D are the remote. Okay, so you can see that they kind of they're actually going to be equal to each other. So A right here is going to be equal to adding these guys up together. That's the relationship, and I can use that to solve a problem. So now I can actually solve this math problem. If I have 40 here and 30 here, I know what this angle is out here. So this exterior angle out here, it's called a remote angle. A little bit more specifically, it's this is an exterior, these are the remotes. So these remotes, I add them up, it tells me that this is 70 right there. Okay, I know that doesn't look like that, looks like an obtuse, but that you would be always adding these guys here to get your outside. It's not to scale right now, so ignore that. The next angle relationship we have is vertical angles. Vertical angles are equal. So vertical angles happen when two angles cross, like this and this. Those are vertical angles. That's A and B, so angle A equals angle B. Right here would be vertical angles. They would be equal to each other. Okay, so what are the measures of angle A, B, and C if given this? So if I'm given this information, I can use the fact that B is vertical to 40. So that means that angle B is equal to 40 degrees. Okay? If I know that this is 40 degrees, I should be able to figure out the rest because this is creating a straight line right here. So 40 plus what gets me a straight line? It's 140. So now we get 180. That's a straight line. So that would mean angle A is 140, which is vertical to C. So angle C is also 140 degrees. The next angle relationship we'll use is supplementary angles. Supplementary angles create a straight line, supplementary straight line, both with an S. Okay? The two angles add up to be equal to 180 degrees. They can be adjacent, which means touching, or non-adjacent. They can be totally separate angles, but as long as they add up and equal to 180, they're considered to be supplementary angles. So I could ask you, I have an angle here that is 45 degrees. What is its supplementary angle? So I'm just asking you, what is the other angle to equal 180? So supplementary would be 135. Okay? Complementary angles is the next relationship. So this video is going to have a lot of them. Fast forward to the ones you need, rewind to the ones you need to revisit. Complementary, I always tell students complement's always the right thing to do, meaning a right angle, 90 degrees. Complements always add up and equal 90 degrees. So again, they could be adjacent or they could be non-adjacent, which means non-touching. So 27, the complement to 27 is 63 because I add them up, they equal 90. Okay, so again, I can solve missing angles using that concept. This visual is going to talk about corresponding, alternate interior, alternate exteriors. Alternate just means like one's on the left, one's on the right. Okay, interior means inside, exterior means they're on the outside. So corresponding, let's just touch base on that. D and H are corresponding. So D corresponds to H. D and H are corresponding. The way I look at that is like, here's a set of angles. This one is in the bottom right of this one. This one's also in the bottom right. That means they're corresponding, which also means they're equal. They're both obtuse. They'd both be equal to each other. So if I pretend that this is 110 degrees, I don't even have to measure it. I know that this is 110 degrees. Okay? D and E are what we consider to be alternate interiors. So if you know this is parallel lines, you notice D is on the inside of these parallel lines. Okay? So D is inside and on the right, where E is inside and on the left. That's that alternating part. The fact that they're both on the insides is the interior part. So those guys are both equal to each other. So again, if this is 110, I also know that this is 110. Okay? Now we go to alternate exteriors. So now I'm thinking outside angles. So G and B. So again, if I look at this pair, G is on the outside. Okay? G would be outside left. This one's outside right. So that's the alternating part. G and B are equivalent to each other. So this would be like 70 degrees. So then I would know that this would also be 70 degrees. The next angle relationship we will work on during this chapter, is that the sum of angles of a triangle always equal to 180 degrees, no matter what. So if I have a right angle here that is 60, 30, add that up, you got 90 and 90, gives you 180. If it's more like this, more of a scalene triangle, got 80 degrees, 70 degrees, 30 degrees, I still have 180. 70 and 30 is 100, plus 80 more is 180. Always is going to happen. So again, I can use that to solve math problems. So if I give you this, again, forget about scale, just work on the numbers there. This guy is, I'll just call him, he's an acute angle, so he's 40 degrees. I'll say this is a little bit obtuse. This is 115 degrees. I can use that to solve this. I can solve x now, because I know 115 plus plus 40 plus x is equal to 180. So I know I'm using up 155 degrees plus something else is equal to 180. I can use that and use algebra. Subtract 155, subtract 155. The remaining is, put 5 more on that, you got 160, so 25 degrees. And so that is the end of angle relationships.